Okay, so now we're going to cover a new topic, which is diagonalization. Now, this is very closely related to the topic that we were covering. So, before we were looking for eigenvalues and eigenvectors, okay? Once you have found the eigenvalues and the eigenvectors, you can diagonalize a matrix, okay? And so, the eigenvectors will form this S, and then we have S's inverse. And so, you'll find the eigenvectors first, okay? And then you'll use the eigenvectors set up in this format, and if it's 3 by 3, then you have the 3 eigenvectors, and you'll have 3 eigenvalues in the diagonal. You're going to use the eigenvectors then to find S inverse, and the eigenvalues themselves are going to form a diagonal matrix that is in between the eigenvectors and the eigenvectors inverse. And this has a lot of really great applications that I'll get into about this. But let's just go ahead and let's do an example of this first. And let's verify that if I find the eigenvalues and the eigenvectors, and I find the inverse of the eigenvectors, that it really does equal the matrix. Okay? So, let's take a matrix. We'll start with a relatively simple one. So let's say A is going to equal 1, 2, 0, 3. Okay? So, right, so step 1 is the eigenvalues. Okay? So, to find the eigenvalues, just like we were doing before, this is going to be the determinant of A minus lambda I, which is going to be the determinant. Now this one is upper triangular, so it comes out very nicely. So this is going to be 1 minus lambda, and 0, and 2, and 3 minus lambda. Okay? So that would just equal 1 minus lambda times 3 minus lambda, well, minus 0, but you don't care about that one, which equals 0. So lambda 1 is going to equal 1, and lambda 2 is going to equal 3. Okay? So those are the eigenvalues for the matrix that we're dealing with. Now that we have the eigenvalues, let's look for the eigenvectors, and then that will give us S, and then we can find S inverse. Okay. So now we're on to step 2. So this is going to be looking for the eigenvectors. Okay. So first one would be A minus lambda 1 I. B1 is going to equal 0. Okay. So A minus lambda 1 I. Okay. That would be 1 minus 1, this would stay as 0, that would stay as a 2, and this would be 3 minus 1, which is going to come out to, all right, it's 1 minus 1 is 0, that stays as a 2, that's a 0, that's a 2. Okay. So if I wanted to get this thing into reduced row echelon form, I would have to say, okay, well, I can eliminate that 2 right there, and I can turn that 2 into a 1, 0. Okay. Now have this guy act upon B1 and say this has to equal 0. Okay. Well, this is kind of a weird case because this guy is our pivot and this guy is our free variable. And the free variable is not affecting the pivot at all. So we're just going to call B1 1, 0. Because if that matrix acted upon 1, 0, no matter what, it's going to produce zeros. Okay? So the first one is just a free variable. And so then we would have A minus lambda 2I V2, which is going to equal 0. Okay? So my lambda 2 is 3. Okay. So A minus lambda 2I is going to equal, all right, so that's 1 minus 3, 2, 0, 3 minus 3. Okay? And so that would equal negative 2, 2, 0, 0. Okay. Well, at this point of the problem, I'm just going to divide by negative 2. And so that'll give me 1, negative 1, 0, and 0. Now, acting upon B2 is supposed to equal 0 and 0. So B2 is going to equal, okay, so that's 1, 1. Okay, so we found B1 and B2. All right. Since we found lambda 1, we found lambda 2, we found B1, we found B2, and so that's going to give us S. Okay? So S is going to, all right, so I'll write it down again. B1, B2 is going to equal 1, 0, 1, 1. All right? Now step 3. Find S inverse. Okay? So, luckily this one's pretty short. Because if I take this bottom row and I multiply by negative 1 and add it upwards, marking 1, 0, 0, 1, augmented 1, negative 1, 0, 1. Turns out the inverse matrix is really easy to find. So that's S inverse right there. Okay, so the last step isn't really a step, but check your work. Okay, so we're going to look at S. S inverse. Okay, so that would be 1, 1, 1, 0, 1. Okay, now acting on 1, 0, 0, 3, 3. Okay, and then acting upon 1, negative 1, 0, and 1. Okay, let's do this in steps. 1, 1, 0, 1. Okay, now let's have this guy act upon that guy. All right, so that would be 1, negative 1, 0, and then 3. Okay? 1, 1 acts upon that would be 1. 1, 1 acts upon negative 1 and 3 would be 2. That would be a 0, and that would be a 3. We get a big check mark. Yes, we did get the correct answer.